Alright, hi everyone, welcome back to the channel. This is the 11th problem solving lecture of this dynamic programming series. In this series, we are covering the first 16 CSES DP problems, and we're also developing a general mindset to approach any new DP problem. Okay, so let's get started with this video and let's start by reading the problem statement. Given an A cross B rectangle, your task is to cut it into squares. On each move, you can select a rectangle and cut it into two rectangles in such a way that all the side lengths of the rectangles that you cut them into, they should be integers. Okay, it is written that we need to find out the minimum number of possible moves such that all these rectangles that you're cutting your current rectangle into, they end up becoming squares. First of all, let's try to understand what essentially is happening in this entire problem. Let's suppose the initial rectangle that is given to you is 5 cross 4. 5 is the height and 4 is the width. What can you do in terms of making a cut? Let's suppose you make one cut here. The first rectangle gets split into 3 cross 4. The second rectangle gets split into 2 cross 4. Another cut you could make here, let's suppose. So now you can say that this is a square, this is a square. Correct? Let's suppose another cut you make here. Okay? And let's suppose you make one cut here and one cut here. Can I say now all the resulting rectangles are squares? This is a square, this is a square, this is a square, and this is a square. But how many cuts did it require us to do something like this? This is the cut number 1, this is the cut number 2, this is the cut number 3, cut number 4, and cut number 5. Can I say it required 5 cuts for me to do something like this, right? Can I come up with a better, method which uses lesser number of cuts? Yes, what we could do is we could probably make a cut here, right? Then this entire is a 4 cross 4 square. This is completely done. Now you could make a cut here, one cut here, and one cut here. Now all the resulting rectangles are squares. Right? In this case, how many cuts have we used? We have used just 1, 2, 3, and 4 cuts. Correct? So this is a better way to solve this problem. Alright, so let's consider some more examples and let's see if we are able to somehow come up with a greedy idea. Okay. One of the examples could be something like 4 cross 3. Okay, so this is a 4 cross 3 grid. One very obvious idea that could come up to your mind is that let's suppose look at the minimum of the two sides and make a cut accordingly. For example, here you can see that 3 is the minimum of the two sides, right? So what you could do is that on the larger side, you could make a cut of this length. Like the minimum side is 3, right? So on the larger side, you could make a cut of length 3 and divide the rectangle into two sections, something like this. What would this do? This would divide one of the sections into a perfect square. This is a 3 cross 3, right? The other rectangle would be something like 1 cross 3. All right, so what I know is that one of the rectangles is now bound to be a square. Got it? Okay, so now we are left with a 1 cross 3, which would look something like this. Now what should I do in this 1 cross 3? Again, use the same greedy idea that, okay, look at the minimum side and make a cut of that length on the larger side, right? So you have something like 1 cross 3. How about we make a cut of length 1? If we make a cut of length 1, can I say one of the rectangles out of the two rectangles is bound to be a square? Yes, because this is a square now. What about the remaining? Like now we have something like 1 cross 2 remaining. Yes. What do we do now? Again, we make a cut of the smaller length on the larger side. So we make a cut here. Yes, this would result into 1 cross 1 cells, which both are squares. Correct? But doing something like this, how many operations did we use? We used one operation here, we used one operation here, and we used one operation here. So we used a total of 3 operations to convert our 4 cross 3 rectangle into squares. What are these squares? This is the first square, 3 cross 3. This is the second square, 1 cross 1. This is the third square, and this is the fourth square. Right? These are the squares that it got converted into. Right? So this is one greedy way in which you could think about this problem. That okay, look at the minimum side and make a cut of that minimum side on the larger side. And by doing something like this, one of the rectangles out of the two that it will result into is bound to be a square. Right? But I'll tell you one thing that this idea doesn't really work. Okay, so if you have a 5 cross 6 rectangle, what is the thing that you would do according to your greedy approach? You would make a cut first of all here, right? Because 6 is the larger side, so you would make a cut making this as a 5 cross 5 rectangle, right? So let's make this cut here, right? So the very first rectangle is a 5 cross 5 square. Okay, so this we are done. We will not look at it again. But the remaining rectangle, what is that? It is now a 5 cross 1. Okay. Now, if you have a 5 cross 1 rectangle, the only way to convert it into squares is to make 4 cuts. Like one cut you will make here, one cut you will make here, one cut you will make here, and one cut you will make here. How many total cuts are these to convert your 5 cross 6 rectangle into squares. These are essentially 1, 2, 3, 4 and 5 cuts. So we just saw that by our greedy approach, we would get 5 cuts through which we will be able to convert this 5 cross 6 rectangle into squares. Okay. And I'll tell you there is another way in which you could make cuts, and that would also result in all the rectangles becoming squares, but that would require lesser number of cuts. Okay. So let's say you make the very first cut here. Okay. This would leave us with 2 rectangles. One of them is like a, 3 cross 6 and the other one is a 2 cross 6. Correct. Now on the 3 cross 6, make a cut in the middle. Let's suppose you make a cut here. What is happening here? Now this part of the rectangle is a square and this part of the rectangle is also a square. Correct? Both of these are 3 cross 3. Now on the other rectangle, 2 cross 6, make these 2 cuts. One cut here and one cut here. Okay, so this would result in this square, this would result in this square, and this would result in this square. Okay, so in total, how many cuts have we made here now? One cut that we made was this one. The second cut that we made was this one. The third cut that we made was this one. And the fourth cut that we made was this one. Okay, so how many cuts have we used now? We've used 4 cuts. In the first case, in the greedy choice, we were making how many cuts? 5 cuts. Correct? So we've just seen how the greedy approach that we came up with is not going to work. What now? What do you do now? If your greedy approach doesn't work, what is the thing that you do? The very first thing that you do when your greedy approach doesn't work is to just try out all the possible ways. Okay. So what are the possible cuts that you can make on this grid? Okay. The very first cut that we're talking about. The first cut that you could make is probably, let's suppose here. Okay. If you make this as your first cut, what is this going to result in? This is going to result in 2 grids. The very first grid will be a 1 cross 4. Yes. And the second grid will be like a 2 cross 4. Correct? So when we made the cut here, we got these 2 separate rectangles. Now this is a different subproblem, let's call it P1. And this is a different subproblem, let's call it P2. So if you look at P1 now, how many cuts are required in P1? Like obviously it is like a 1 cross 4 grid, right? So you would have to convert this entire grid into 1 cross 1 squares. So you would make the first cut here, the second cut here, and the third cut here. Okay. So this required 3 cuts. What about P2? And I can say that, okay, P2 is just going to require 1 cut because it is going to split into 2 cross 2 and 2 cross 2. So this required 1 cut. If you would have gone with this route of making a first cut here, how many total cuts are you having to do? You're having to do 3 cuts here, plus 1 cut here, and plus 1 cut here. Because you will essentially split this rectangle into 2 rectangles, right? So how many cuts are you making here? You're making 5 cuts. Yes, this is one of the ways of making a cut. Let's try out one more way. Let's suppose now you make the very first cut as this one. If you make this as the very first cut, what are the 2 rectangles that you get? The first is 3 cross 3. And the second one is 1 cross 3. Okay, this is 3 cross 3 and this is 1 cross 3. If you have 1 cross 3, how many cuts is it going to require to convert it into squares? It is going to require 2 cuts. So this is 2 and this requires 0 cuts now because it is already a square. So how many cuts in total now? See, 0 plus 2 plus 1, this one. So this requires 3 cuts in total, right? So what are we doing here? We are essentially trying out all the possibilities, right? Okay, so if this is an A cross B grid, what are the different first cuts that are possible? Okay, so if you make the very first cut, let's suppose here, what does this split the entire rectangle into? It first of all splits the rectangle into something like an A cross 1. And the second rectangle it splits into is something like A cross B minus 1. Yes or no? This is the very first cut. If you make it, let's suppose, instead of this, let's suppose you made the cut here. Let's suppose you made the cut here. What is this going to result into? This is going to result into something like A cross 2 and something like A cross B minus 2. Yes. What would we do now? If we are having, like if we have an A cross B grid and if we just try out all the possible ways, like we are making one cut, we are splitting the entire rectangle into 2 parts, correct? One of them is A cross 2 here and the other one is A cross B minus 2. Similarly, if you would have made a cut here, let's suppose, this would have resulted in 2 different rectangles. Now here we're just talking about vertical cuts. You could also make horizontal cuts. That would result in completely different rectangles, right? So can I say if I know the number of cuts required to convert this A cross 2 into squares, let's call it something like X. And if I know how many cuts are required to convert A cross B minus 2 into squares, let's call it Y. The total number of cuts required to convert A cross B into squares such that the very first cut that you make is this orange cut is going to be how much? It is going to be X plus Y plus 1. Y plus 1 because initially we are making this orange cut and then it gets split into a cross 2 and a cross b minus 2. We also know that a cross 2 requires x steps and a cross b minus 2 requires y steps. So in total, it requires x plus 1 plus y. Okay, so if you have a cross b, what are the different cuts? Let's first of all look at vertical cuts. What are the different vertical cuts that you could make? Can I say on the very first vertical cut, it gets split into a cross 1 and a cross b minus 1? Yes. So the very first vertical cut that you could make is something like a comma 1 and a comma b minus 1. The second vertical cut that you could probably make is something like a comma 2 and a comma b minus 2, right? And so on. You could make how many cuts, right? So the last cut that you could make is something like a comma b minus 1 and a comma 1, right? So these are all the different cuts that are possible. How would you find out the total number of cuts required for one particular possibility? Like, let's suppose you went with this possibility. What are the total number of cuts that would be required? Can I say the total number of cuts required here plus the total number of cuts required here plus 1? This is the final number of cuts required if you go with this possibility. Yes, because see, we are just saying that, okay, we want to solve this a comma b. A comma b is like saying number of cuts required to convert this a cross b into squares. Then we said that, okay, make a vertical cut which divides the entire rectangle into a comma 2 and a comma b minus 2, right? Now, if we know what is the number of cuts required to convert a comma 2 into squares, and we also know what is the number of cuts required to convert a comma b minus 2 into squares, we will just have to add this plus 1 to find out the total number of cuts. And we can just take the minimum over all these possibilities to find out which is the best vertical cut. Correct? Whichever is the best vertical cut, we would take that as the answer for vertical cuts. What about horizontal cuts? Let's suppose you had a comma b, and now you're concerned about horizontal cuts. Okay, so the first horizontal cut that you could make would be something like, let's suppose you have a cross b, so you would make 1 cross b and a minus 1 cross b, right? So you would have 1 comma b and a minus 1 comma b, right? This is the first horizontal cut that you could make. Second horizontal cut that you could make is something like having 2 rows in the top and then a minus 2 rows in the bottom. So this would be something like 2 comma b and a minus 2 comma b, right? So similarly, these are all the possibilities of making a horizontal cut, right? This would eventually become something like, final cut would be something like a minus 1 comma b and 1 comma b. Alright, so now can I define my DP state as something like this? DP of n comma m is equal to minimum number of cuts required to convert n cross m rectangle into squares. Yes, and what is going to be the transition now? See, if you have n as the height of the rectangle and m as the width of the rectangle, what is the very first cut that you could make? Let's look at the vertical cuts. If you're looking at the vertical cuts, these are the cuts that you could make, right? So can I say, if I'm making a vertical cut, then how many total cuts that would require? Like, if you make a cut of length 1, that would be dp of n comma 1 plus dp of n comma m minus 1 plus 1. See, if you're making the first vertical cut as this green one, which splits the first rectangle into something like n cross 1 and n cross m minus 1. And with that definition, dp of n comma m is the minimum number of cuts required to convert an n cross m rectangle into squares. So if I want to convert n cross m into squares, and if this is the very first cut that I'm making, I'm adding plus 1 for that. And then I'm saying, okay, convert this n cross 1 into squares, that would be dp of n comma 1. Convert this n comma m minus 1 into squares, that would be this. Yes. So what I would do is that I would try out all the possible ways, all the different vertical cuts that I can get. So can I say my best vertical cut is this? If I have to find out the best vertical cut, this would be nothing but something like dp of n comma I plus dp of n comma m minus I plus 1 for all I going from 1 to m minus 1. Yes, I'm looking at all the possible vertical cuts that I could get. I would take the minimum of all of these. Okay, that is the best vertical cut that I can get. Similarly, what could be the best horizontal cut? Like, if you're making a horizontal cut, how would that work? See, if this is n cross m, your horizontal cut would look something like this, right? You would make the horizontal cuts like this. If let's suppose this is the first horizontal cut that you're making, what is this splitting the rectangle into? It is splitting the rectangle into 1 cross m and n minus 1 cross m. Yes, so what is going to be the DP states for these? This is simply going to be DP of 1 cross m, and this is going to be DP of n minus 1 cross m. Yes, and you would add a plus 1 to find out the total number of cuts required to convert n cross m into squares such that you make a horizontal cut. So what is going to be your best horizontal cut? You would try out all the possible ways. So can I say best horizontal cut is going to be simply dp of I comma m plus dp of n minus I comma m plus 1. I would take the minimum of this for all I going from 1 to n minus 1. Yes or no? Got it? So this is what we could do. Like if you have an n cross m rectangle, the best way to make a cut is to just try out all the possible ways. Try out all the vertical cuts, try out all the horizontal cuts. Whichever of them, the minimum of all of these that you get is going to be your final answer. Correct? Again, remember what is the DP state? DP of n comma m is the minimum number of cuts required to convert n cross m rectangle into squares. Got it? Now what is going to be the base case? Where is this going to end? Like where would you not have to make any further cuts? Can I say if you have something like this, let's suppose this is I and this is also I. If you have an I cross I grid, do you really need to make any more cuts? No. So what I can say is that something like dp of I cross I is going to be 0. Because if you already have a square, you don't need to make any further cuts. This is going to be the base case, okay? So you're going to do this for all I, okay? Going from, let's suppose, like minimum of 1 to minimum of n comma m, okay? Like for all dp of I comma I, it is going to be just 0. You don't have to make any more cuts to convert it into squares because it is already a square, right? What is going to be your final subproblem? This was the base case. See, in the problem statement, it is given that you have an A cross B rectangle that you want to convert into squares. So your final subproblem is simply dp of A cross B. This is final subproblem. Yes. What is going to be the time complexity? See, if you look at time complexity, it is number of states times average transition time. Okay, how many states are here? We have A cross B rectangle that is given to us in the problem statement, and A and B both are going up till 500. Okay, so in terms of the number of states, you have A cross B, A multiplied by B. Okay, what is the average transition time? If you have an A cross B rectangle, right, you're going to try out all the possible vertical cuts. How many vertical cuts are there? There are basically B minus 1 vertical cuts or order of B vertical cuts. And you're also going to try out all the horizontal cuts. So can I say the total transition is simply going to be number of vertical cuts plus number of horizontal cuts. So this is going to be multiplied by order of B, which is the number of vertical cuts, plus order of A, which is going to be the number of horizontal cuts. Okay, so this essentially comes out to be something like order of A square B plus AB square. Okay, all right, so let's look at the code for this problem. We have these inputs, integer A and B, which is the sides of the rectangle. We define our dp vector as the 2D vector of A cross B, right? And then we say dp of I comma j is the minimum number of cuts to break a block of I cross j into squares. All right, and we clearly saw that, okay, dp of I comma j, what are the values that it depends on? See, when I say dp of I comma j or dp of n comma m, doesn't matter. What does it depend on? It depends on dp of I minus some value comma j. It depends on dp of I comma j minus some value as well, right? These are the two types of dp states that it depends upon, right? So we know for a fact that when we have to write down the for loops, for I it is going to go from 1 to n or 1 to A is the side of the rectangle, and for j it is going to go from 1 to B, correct? So essentially, because your current state depends on previous states, both in terms of row and in terms of column. Okay, all right, so this is how the for loops would be written. So what I'm saying here is that I is the height and j is the width. Now if I equals to j, this was our base case, right? dp of I comma I has to be equal to 0. No cuts are required. So this is what I'm doing. If I equals to j, if the height is equal to the width, then no further cuts are really required. So dp of I comma j is 0. All right, so next what do? Next you can make a vertical cut or you could make a horizontal cut. You would try out all the possible cuts and just take the minimum of these, right? So this is the case where you make a vertical cut. So when I'm making a vertical cut, I'm saying dp of I comma j is minimum of dp of I comma j and dp of I comma v, which is the first side of the rectangle, dp of I comma j minus v, which is the second side of the rectangle, plus 1. Right? Why plus 1? Because we made a cut here. Similarly, for the horizontal cuts, I would just try out all the possible horizontal cuts and I would take the minimum of all of these, right? So this is the place where I'm taking the minimum across all the horizontal and the vertical cuts, right? So that's the transition. Final subproblem is this, like we've already discussed. Okay. So yeah, that was it for the solution for this problem. I hope you found it interesting. So yeah, in case you've understood everything, just feel free to comment understood in the comment section. And don't forget to subscribe to the channel and press the bell icon to not miss any future updates on the series.